This is lesson 5, axis of symmetry in standard form. And we are going to start, we're skipping the word symmetry, which we've talked about. The axis of symmetry is this line of symmetry right in the middle, which both sides of the parabola mirror. They mirror. So it's the line of reflection. It's always written in the form x equals h. And when we did that really long assignment with all those graphs and we wrote our axis of symmetry every single time, h is the exact same h as the number of the vertex, the x part of the vertex. They are exactly the same. So this equation is given to us in vertex form. We can see our transformations. We can find our vertex quickly. This is vertex form here. Vertex form. So we're going to label the vertex in the axis of symmetry, and we're going to graph. So the vertex, we're looking inside of the squared, and we're looking for a horizontal translation. And Nina, can you tell me what the horizontal translation is? A little bit louder, huh? Left 3, yep. So my vertex is going to start with -3. And then we go on the outside, we look at that +4. And Ryan, what's the +4 become in my vertex?
Just 4.
Just 4? Yep. So my vertex is at -3, 4. See, what else do we know about this parabola? Is it going to open up or down? Down, because we have a negative sign on the outside of this parabola telling us there's a reflection in the x-axis. So we know it's going to open down. I should now know my axis of symmetry. My axis of symmetry comes from the vertex. X equals, you just take the x part, -3. And the axis of symmetry is a vertical line that passes through the vertex. So there's my mirror line. Now we just need some more points, so we could potentially just graph this. We need at least 5 points to graph it. I have 1 point. So I need at least 4 more, maybe more, but I need at least 4 more. So for this one, because it is in vertex form, I can do transformations. So I'm going to start with a transformation table. Because it's in vertex form, I can do transformations because it's in vertex form. We've got a -2, which is telling me a reflection in the x-axis and a stretch. But in my table, I just multiply all my y's by -2. And now I've got a really big number that's probably not even on the graph. So that's why I always do 7, just in case there's ones that don't fit. We have that -3 for the x's. So I'm going to subtract 3. And add 4 to the y's. And again, here's my vertex right in the middle at -3, 4, which I was able to find without even making a table. And I'm going to plot some more of these points. Around the vertex, I've got -4, 2. That is not the right one. -4, 2, and -2, 2. And we've got -1, -4, and -5, -4. And then after that, it's off the graph. But I do have at least 5 points. So it's good. everything we did right there should be review. Okay. If I'm going too fast, I am creating a video right now. Let's just talk about the vertex. I don't want to take the time to graph all of these because this would be a very good review if we were on a different day. But since we were just doing vertex form, we just graphed one, we're going to keep moving on. Graph the function, label the vertex, axis of symmetry. Let's just do vertex and axis of symmetry. So for this one, the vertex for this one. Emma, can you help me with the x part of the vertex? Left one. So my x part of my vertex is going to be what, Emma? -1, correct. And then the y part of the vertex. Renee, can you help me, Renee, with the y part of the vertex? It's that number that's added or subtracted at the end of this. Great. Good job. So look, that was the first one that we've seen that had a 0 for the y. Now the axis of symmetry. Sierra, can you help me with my axis of symmetry? Nope. The axis of symmetry number is already on here. So we go back to the previous page. Right, but it's not just -1. It is an equation. So if you just write -1, it's going to be wrong. We need x equals -1 for our axis of symmetry. So I know that my vertex would be at -1, 0. My axis of symmetry would be here at -1, and I'm not going to graph the rest of it, but that's where it would be for the center part. Let's do the vertex and the axis of symmetry for the next one. Ella, the vertex, we're going to use this number here. It's going to give me the x part of the vertex. What x part of the vertex should it be? What number? Louder. Yes, 2. It's positive 2. And then the y part of the vertex. Katsia, what will the y part of the vertex be? Yes, -5. And then our axis of symmetry. Warren, can you tell me the axis of symmetry? Something 2. X equals 2, perfect. X equals 2. Oops, 2. And then if I graphed it, which I'm not going to, 2, -5, and then x equals 2, and then the parabola would be around that somewhere. That would be the center. Okay, this is the new stuff. Standard form is a new form. So this is not vertex form, but they are the same equation. This is not vertex form, but they are the same equation. And we can derive standard form by taking this equation and multiplying it out like we did on the previous notes, but we had numbers. I'm going to do it really fast. You guys are going to copy down. We're not going to worry so much about step by step, but I'm just showing you that these are going to be the exact same line by taking one equation and changing it into the other. That's all I'm trying to do is just show you that they're the exact same, and I think I said line, I meant parabola. So I would take A and I would multiply it by x minus h plus k. Oops, that's k. So I would multiply this together. And if you wanted to do x minus h and x minus h as a box, you could. When I multiply that out, I get x squared minus 2hx plus h squared plus k. And then I'd have to distribute my a. And then when we look at the A in the two forms, so this is the only part that really matters here. When we look at the A in both forms, they're both just A by themselves out front being multiplied. This is the A in both forms. They're going to mean the exact same thing in both forms. It's a vertical stretch or a shrink. Could be a reflection in the x-axis. The B is this term right here. This is bx in the new form. I'm sorry, I don't even know if I said this out loud. Let's do this here. ax squared plus bx plus c. And so this middle term with just the x is the bx from here. These match up. So this says I'm going to take b equals, and I'm going to solve h to obtain h. So if I have this right here, bx is equal to negative 2ahx. And then I'm going to solve this for h. That's what it says. I'm going to solve that for h. I'm going to divide both sides by x. You guys don't have to write all this stuff down. You're just going to fill in the blanks. And then I'm going to divide both sides by negative 2a. And I get that h equals b over negative 2a. So negative b over 2a. This here is going to be our axis of symmetry. And when you think back and you say, how do these mathematicians even come up with these formulas? This is what I'm doing right now, but I don't expect you in Algebra 2 to understand it 100% the first time you've ever seen it. That's why I'm going through it fast, because we don't really need to totally understand it. I just want you to see how mathematicians come up with this stuff, the formulas, but you have to memorize the formula. So the axis of symmetry is x equals negative b over 2a. This is a memorization. And then we look at the last stuff. C is ah squared plus k. And if we do f of 0, we get ah squared plus k. If we do f of 0, this is telling me that C is the y-intercept. That's the part you really need to know, is that C is the y-intercept. Okay. Let me actually do problems with it. Skip ahead here. Okay, so what you're going to do is graph an equation. It's in standard form. You will notice that this form is ax squared plus bx plus c. That is in the form where it's all multiplied out, where we don't have the parentheses squared. Ax squared plus bx plus c. So what's a in this form? Yell it out. What's that? What's the little a? 3. Thank you. One person. What's the b? Corey, b.
6.
Almost. Try again.
1.
No, not even close. I said almost. What's the b?
Negative 6.
Negative 6. Thank you. And the C. Ebony. 1. We got A, B, and C. We are going to find the axis of symmetry, which is the AOS. We're going to use a formula that I just wrote down on the other page, and you're going to write down this formula every single time until you have it memorized. X equals negative b over 2a. And then we're going to plug in things. We do negative. Now we're going to plug in b, which is negative 6. Over 2. Then we're going to plug in a, which is 3. So I plugged in b, I plugged in a. And I simplify that. I get positive 6 over 6, which is 1. My vertex is x equals, that is not my vertex. That's my axis of symmetry. Sorry. X equals 1. That is my axis of symmetry at x equals 1. So I'm going to go over to my graph, and I'm going to find where x equals 1, and I'm going to graph a vertical line up and down. That is my axis of symmetry. My parabola will be centered on this line somewhere. So now we got to find our vertex. And because the vertex and the axis of symmetry have the same x value, to find the vertex, we're going to plug in the AOS and solve for y. So I'm going to do f of 1 to my equation. 3 times 1 squared minus 6 times 1 plus 1. So 3 minus 6 plus 1. Negative 2. So my vertex is the x from the AOS and negative 2 that I got from plugging in the AOS into the equation. That's my vertex. 1, negative 2. That's my vertex. We have 1 point. We need at least 5. Yes?
So when you went from the 3 and then 1 squared, you
I did 1 squared.
yeah, where did that
Where'd it go? Is that what you
Yeah.
said? Where'd it go?
like where'd the 1 squared go?
What's 1 times 1?
Oh, never mind.
1
Yeah.
times 3. 3. So it just went, I just did it really fast and put it there. Okay? All right, we have 1 point. We need at least 5. So we need to find some more points. Another good thing to find would be the y-intercept. And as I mentioned super fast, but I don't really focus on it so much, is we can find the y-intercept really fast. You plug in 0 for x into the equation, so 3 times 0 squared minus 6 times 0 plus 1, and we get 1. So my y-intercept is at plug in 0, get out 1. 0, 1. So now I have 2 points. I need at least 5. So we're going to use the mirror. If I have a point on one side of the mirror, then I actually can reflect it over to find a point on the other side of the mirror that matches up with that y-intercept. How many points do I have? 3. How many points do I need? 5. So it looks like I'm just going to have to pick another x to plug in. I have to pick another x. So we want to start thinking about this smart. Less work when we're smart. So far, I know my parabola looks like this. So the x values that I know are 0, 1, and 2. What could be another x value that I could plug in? Not 0, 1, and 2. Any number, not 0, 1, and 2. Somebody yell out a number.
4.
4. Let's pick something smaller because it's not going to fit on the graph. 3. Okay, let's pick 3. So we're going to do f of 3. I don't even know if f of 3 will fit on the graph. We'll see. F of 3. So we're going to do the equation 3 times 3 squared minus 6 times 3 plus 1. So I plugged in 3. I'm going to get 27 minus 18 plus 1. 10? Is that it? Yeah. 10. So 310. I'm going to go grab 310. I have 4 points. How many do I need? Should I plug in another number? Should I plug in another number? If you're agreeing with me and saying no, what else could I do? I need 5 points. Jackson?
You can just reflect the dibs.
Reflect the one we just found to the other side. I'm not going to waste my time plugging in numbers. It's symmetrical. So we're going to reflect that one, and now we have 5 points. And we got a graph. Yay. Let's do another one. Let's do number 2. Number 2 looks like there's more going on. Let's do number 2. So we're going to start by finding our axis of symmetry. We're going to start by finding our axis of symmetry. So we write down the formula. X equals. Holland, what's my formula for axis of symmetry?
B over 2A.
So you're missing part of it. Do you have it written down? Here's mine.
Negative B over 2A.
Negative b over 2a. Negative b over 2a. We write the formula down every single time so we can remember it. Wrote my formula down. Now we're going to plug some stuff in. Oh, I didn't say what A, B, and C are. So A is negative 2. B is negative 8. C is 1. So now I can plug my stuff in. So I'm going to write X equals negative. Now we have to go with B. Macy, what do I put on top? I'm putting B on top. So what number is B? I wrote it right above where I'm going to plug it in. So, say it again. Negative 8. Over. I do 2. Then I multiply it by A. Gennaro, what is A? I wrote it down. I wrote A. What's A? Negative 2. So I put it in the spot where A goes. Now I'm going to simplify that. X equals, I get positive 8 over negative 4. So X equals negative 2. There's my axis of symmetry. I go to X equals negative 2 and I make a vertical line. Vertex, you have to plug in negative 2. Now, do I always plug in negative 2? No. I'm plugging in my axis of symmetry into the equation. So we do negative 2 times negative 2 squared minus 8 times negative 2 plus 1. Negative 2 times 4 plus 16 plus 1, so negative 8 plus 16 plus 1, so 8 plus 1, 9. Negative 2, 9. My graph, negative 2, 9. I have 1 point on the graph. I need more than 1. I need 5. What else could I find, Nina? What else could I find? Y-intercept. Okay, so we're going to find our y-intercept. We're going to do that by plugging in 0. So I do f of 0. Oh, it's p of 0, my bad. P of 0. So I have negative 2 times 0 squared minus 8 times 0 plus 1. We get 0, 1. Oh my gosh, stop moving. Sorry. 0, 1. Good, I have a y-intercept at 0, 1. So Sophie, now how many points do I have? Do I really have 2 or do I have more? 0. I can reflect that one, and now I actually have 3 points. So I look at where my x's are. I have an x at 0. I've got an x at negative 2. I've got an x at negative 4. That's where my points are. What x can I plug in? Don't plug in 0, negative 2, or 4 because we already graphed those. What x could I plug in? Grace, what x can I plug in that's not 0, not negative 2, not negative 4? Wait, what was your answer? I'm asking you to pick a number that's not 0, not negative 2, and not negative 4. 3. Way over here? Yeah. Oh, negative 3 might be a better one to pick, yeah. Something in between here. Grace, would you rather plug in negative 3 or negative 1? Totally up to you. Okay, we'll plug in negative 3. You guys get to choose which one. That's why I asked her. But they really should give you the same y no matter which one you plug in. So I'm going to do p of negative 3. And that's going to give me negative 2 times negative 3 squared minus 8 times negative 3 plus 1. So negative 2 times 9 plus 24 plus 1. Negative 18 plus 24 plus 1. 6 plus 1, 7. So I have negative 3, 7. And once I have that negative 3, 7, that means I also have negative 1, 7. And I have at least 5 points, so I can create my parabola. That side was kind of crazy. Okay, I want you to try the easier one. Question 1, the student practice. I want you to find the vertex of the axis of symmetry, the y-intercept, have enough points plotted. Ask me questions. I'm going to walk around and peek over your shoulders. Write the formula every time until it's memorized. Write your formula every time until it's memorized. We still have connection issues?
it goes back and then it like it works and it doesn't.
So, just looking over one person's shoulders, I want to make sure that everybody knows what A, B, and C are. A, because there's an x squared there is an x squared. It's not 0 in front of it. Because if it's 0, there'd be no x squared. A would be 1. B is 2, C is -1.
So what's the formula for axis symmetry? You didn't write it here. What is the formula? Okay, so did you do negative b over 2 times a? So if that's wrong, it's going to make the vertex wrong too.
You're doing it in your head, so wheels are turning. All right, so the axis of symmetry to start, you have to do x equals -b over 2a. So I'm going to plug in b, which is 2, over 2 times a, which is 1. It's going to give me -2 over 2. So my axis of symmetry is x equals -1. Now, if you have the axis of symmetry wrong, and then you go plug it in, you're going to get the wrong vertex. But at some point, you should realize you're doing something wrong because your vertex and the rest of the points aren't going to match up right. Like something's going to look wrong. So to find the vertex, we're going to do, what letter is this one? H. Do h of, and I'm going to plug in -1. So I'm going to do -1 squared plus 2 times -1 minus 1. And -1 squared is 1 minus 2 minus 1. And I get -2. My vertex, -1, -2. Now I got to find some more points. So I'm going to go find the y-intercept. I'm going to do h of 0. 0 squared plus 2 times 0 minus 1. So my y-intercept is 0, -1. The y-intercept gives me a second point. Will it always give me a second point? Every single time? Is there a case where I won't get 2 points for the y-intercept? Okay, that you might figure it out. The last thing we have to do is make sure we have 5 points and I only have 3. So I need to plug in more points. Did anybody plug one in? What'd you plug in, Tessa? Plugged in 1, okay. So I'll do h of 1 in all my space that I don't have. Find a different location. I'll do h of 1 down here. So I get 1 squared minus 2 times 1. Wait, is it plus 2 or minus 2? Plus 2. Minus 1, so we get 1 plus 2 minus 1, so I get 3 minus 1, 2. 1, 2. And from that, we can get a mirror point. Something you might notice is that there is not a stretch on this. There wasn't an a value in front. So this equation, and you can notice by looking at the points, is like the normal parent function that was translated. So if I notice it's up 1, or out 1, up 1, out 2, up 4, then it's going to hold that same pattern because there wasn't a stretch. So I actually could find more points by just knowing that original transformation pattern that we did a lot prior to today. So that's what the graph should look like. So for your assignment today, we didn't get as far as I would have hoped. So you are just doing through lesson 5. It says do only 1 through 9. For lesson 5, do only 1 through 9. I will move lesson 6 to the next day. It's there temporarily. I'll move it to the next day. Okay, so you've got your 2 lesson 4 and lesson 5 worksheets to work on. And then I'll put uploads for those soon as well.